Mutations. So mutations cause changes in protein function through the loss of a function or through the gain of a function. An example is the case for when a mutation encodes for a growth factor receptor that overstimulates that growth factor, triggering consistent growth, even in the absence of a growth factor signal. So imagine a protein as a key, and this key is what turns on this industrial machine that automatically makes fresh baked muffins. This key is what activates the machine to turn on and pump out those muffins. Say the key changes shape and the key gets stuck in the keyhole, keeping the muffin machine turned on, and so now the muffins are being made at a constant and rapid pace that can't be stopped. In the same way, protein shape change can affect the functionality of the protein and result in changes in the actual cell. One specific example of this is called insertion. In the cell, the mRNA is transcribed into proteins with the help of tRNA. tRNA is a molecule that is able to transport amino acids after having translated the codons by matching up anticodons. tRNA can only see in threes. After having read the 3 base pairs of an mRNA, tRNA registers the 3 base pair codon and transports a protein. In the example of insertion of a base pair, something called frame shift can occur. So a base pair that is not originally meant to be in the sequence is added into the line of bases. Keeping in mind that the tRNA can only see in groups of threes, the addition of the base pair will shift the reading frame of the tRNA. What the tRNA used to see as UUC is now changed to seeing AUU due to the insertion of the A base pair, which can be seen in red. Looking at this in a more analytical perspective, each protein has specific codons that code for those specific amino acids. Some proteins have more than one codon, while others have only one, like the start codon AUG that codes for methionine. Looking at the mutated mRNA sequence as well as the resulting proteins, it is easy to find where the mutation might have occurred. The first step would be going through the individual proteins to see where the mutation occurred. Once that is identified, begin to match up the actual base pairs to see how the frame shifted. In this case, there was an insertion of an A base pair. As this occurs, the 3 base pairs begin to shift. Now O is UUU is AUU, and the last C in the previous 3 pair codon is now paired with the A and U that comes after it. The shift occurs throughout the entire mRNA until a stop codon is reached. Thank you.